Hello students, this is Professor Lee. Today we're going to investigate the motion of a bicycle wheel which undergoes simple harmonic motion. For this, first we're going to quickly review the important concepts for this lab, and then we're going to do the lab activities to measure the acceleration of a bicycle wheel using a Bluetooth accelerometer. As you just discussed, simple harmonic motion shows a periodic motion in time. In other words, a motion will repeat after equal interval of time. And we learned the motion will show sinusoidal motion, and therefore we can express this simple harmonic motion as a function of a sine or cosine with a constant frequency. As we see in this figure, if we apply a constant speed of rotation to this bicycle wheel, this motion will show this sinusoidal behavior in time because it will be simple harmonic motion. In this sinusoidal graph, we see the maximum displacement of the motion tracker on this bicycle wheel will be this much, and therefore this will be the amplitude of the motion. We also learned the period will be the time to complete one cycle, and therefore this must be the period. And this sinusoidal behavior will repeat over the time in simple harmonic motion. In motion analysis, we also learned that the frequency information is very important to analyze to see what is going on in the system. We learned the frequency has two different types of frequency. One is the linear frequency, which is the number of oscillations per second, and its unit is hertz or cycles per second. Linear frequency has a reciprocal relationship to the period, and therefore, once you find the period from your measurement, we can also calculate the linear frequency using this formula. Another type of a frequency is an angular frequency, which explains the number of oscillations to complete one cycle, which is 2 pi radians. Therefore, angular frequency omega can be found by 2 pi radians per period. Also, we know the period is reciprocal of the linear frequency, and therefore angular frequency also can be calculated using the linear frequency information as we see in this formula. And the unit of angular frequency is a radian per second. Therefore, once you know the period from your acceleration measurement, you can calculate both linear and the angular frequency as well. And this will be your data analysis after your measurement in this lab.